every composite number can be expressed in the form of product of the prime numbers, and its factorization is unique apart from the order in which prime factor occurs. So this is the fundamental theorem of arithmetic. Now, so whatever the composite number we have, so every composite number can be expressed in the form of the product of prime numbers. That is nothing but what? The fundamental theorem of arithmetic. Now, if I have a value 24, we know that 24 is a what composite number? 24 is a composite number. When you write 24, okay, as a product of prime numbers, this can be written as 2 12s are 24, after that 2 6s are 12, 2 3s are 6, after that 3 1s are 3. Now, 24 can be written as what? So 24 can be written as 2 to the power of 3 into 3 to the power of 1. 2 to the power of 3 into 3 to the power of 1. So we know that 24 is a composite number. Now 2 to the power of 3, that is nothing but 2 is a product of 2 to the power of 3 is a product of prime numbers, and 3 to the power of 1 is also the product of prime numbers, right? So that every composite number can be expressed in the form of the product of prime numbers. So which is a unique, if you write in a what this order, so that is about a fundamental theorem of arithmetic. Yeah, coming to the next concept, fundamental theorem of arithmetic. So here in fundamental theorem of arithmetic is nothing but what, sir? Every composite number, okay, composite number, we know the numbers has been divided into two types. One is a prime numbers, another one is a composite number, and we have a special number 1 that is nothing but, okay, that is neither belongs to the prime nor belongs to the composite. Okay, it is neither prime nor composite. Now you know what are the prime numbers? What are the prime numbers? The prime numbers which are having only two factors, namely number 1 and itself, right? Now coming to the composite numbers, numbers which are having more than two factors, or else other than prime numbers and 1, rest all the numbers are composite numbers. Now if you take some composite numbers, like if I take a number, first composite number, the least composite number 4. So here 4 can be written as what, sir? 4 can be written as 2 into 2. So when you observe 2 into 2, okay, so here the composite number 4 is expressed in the form of the product of the prime numbers. We know that 2 is a prime number and 2 is a prime number. Yes or no? So the product of prime numbers, the composite number, can be expressed in the form of product of prime numbers. If I take number 121 can be written as what, sir? 11 into 11. So 11 is a prime number as well as 11 is also a prime number. The product of these two prime numbers is a composite number 121. So if you take a number 32, so 32 can be written as what, sir? 32 can be written as 2 into 2 into 2 into 2 into 2. Right. So 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. Now 32 is a composite number which is expressed in the form of the product of prime numbers. So if you take number 6, for example, if you take number 6, 6 can also be expressed in the form of what? So 2 into 3. 2 3s are 6. Now when you take these two numbers, so 2 3s are 6. So 6 is a composite number. The product of these two prime numbers, the results give the composite number. Yes or no? It means what? Every composite number can be expressed in the form of product of primes. So the same way composite number is expressed in the form of product of primes. 121 is a composite number which is also expressed in the form of what? Product of the prime numbers. Clear? Now here the product of prime numbers, okay, the composite numbers can be expressed in the product of prime numbers in a unique way. For example, if I have a number 144, now is this 144 is a what? Composite number or not? Yes, obviously 4 is an even number, so that the number 144 is a composite number, right? When you write the factorization for the number 144, 2 7s are 14, 2 2s are 4, after that 2 36s are 72, after that 2 18s are 36, after that 2 9s are 18, after that, okay, 9 is not divisible by 2, again I need to divide with the number 3. So 144 can be expressed as what, sir? 2 into 2 into 2 into 2 into 3 into 3. Yes, sir. So 2 2s are 4, 4 2s are 8, 8 2s are 16. So 144 can be expressed in the form of what? 2 to the power of 4 into 3 to the power of 2, 3 to the power of 2. Clear. So when you observe, the composite number 144 is expressed in the form of 2 to the power of 4 and 3 to the power of 2. So the product of prime numbers and the product of prime numbers. Clear. So every composite number can be expressed in the form of the product of prime numbers. That is nothing but the fundamental theorem of arithmetic. The fundamental theorem of arithmetic. Yes. Coming to the next question, consider the numbers 4 to the power of n, where n is a natural number. Check whether there is any value of n which 4 to the power of n end with digit 0. So we have to check whether 4 to the power of n, for any value n, we have to check whether the last digit is 0 or not. We are getting 0 in the units place or not is the question, right? Now 4 to the power of n can be expressed in the form of 2 to the power of 2n. Am I right? 2 to the power of 2n, right? So I am writing 4 in the form of 2 to the power of 2 into n, right? So here when you take 2 to the power of 1, we know that the digit will be ends with 2. When you take 2 to the power of 2, the digits will be end with 4. When you take 2 to the power of 3, the digit is ending with 8. And when you take 2 to the power of 4, the digit is ending with 6. Okay, 16. 2 to the power of 4, 16. So the digit is ending with 6. 2 to the power of 5, again the digit is ending with 2, 32. The digit is ending with 2. 2 to the power of 6, the digit is ending with, okay, 4. Yes or no? 64. Now 2 to the power of 7 is equals to 128. The digit is ending with 8. Yes or no? When you observe, the number 2, number 4, number 8, okay, 4, 2, 8 and 6 are repeating. So do we have a possibility to get 0 in the units place? Obviously no. When it is in the form of 2 to the power of 2n, so it is not possible to get 0 in the units place. It is not possible to get 0 in the units place.